Hello, this is Oblivious Alsk, now in Eugene, Oregon, as you can see by the difference of backgrounds. And I bring to you Science or Not, a show where I talk about very interesting science things, at least interesting to me, or now and then something that's not science whatsoever. So without dilly-dallying, let's go on to the first subject. And it has to do with Yellowstone. Yellowstone National Park, that is, and everything that lies under it. Some new tests have been done on Yellowstone, specifically that huge volcano that exploded in the movie 2012. Please don't sue me, I'm not making any money off of this. And the results of these tests are showing that the underground plume is much larger than we thought it was. There's nothing in this article that says the chances of a cataclysmic eruption at Yellowstone are any more or less likely to be happening anytime soon, but it gives the scientists a whole new perspective on how huge the reservoir of fiery material that feeds these eruptions is. But to give you a little history on the matter, because everyone loves history, especially when it involves fiery plumes of death. Almost 17 million years ago, a deep plume of partly molten rock called the Yellowstone hotspot first breached the surface in an eruption near what is now the borders between Oregon, Idaho, and Nevada. As North America drifted slowly northwest over the hotspot, there were more than 140 huge eruptions called gargantuan caldera eruptions, which are the largest kind of eruption on Earth. And then the hotspot finally reached Yellowstone about 2 million years ago. When this happened, 3 more of these huge caldera eruptions went about 2 million years ago, 1.3 million years ago, and 642,000 years ago. Now if you do the math, we're due for another one any minute. But you can never tell with stuff like this. Anyway, previous measurements of the plume were done by using seismic waves, which are the same kind of waves that are generated by earthquakes, to create a picture of the underground region. But this new picture was gotten by testing electrical conductivity, which is generated by molten silicate rocks and hot, briny water that is naturally present and mixed with the partly molten rock. The geoelectric and seismic images of the Yellowstone plume look somewhat different because there are slightly different things being imaged here. Seismic images highlight materials such as molten or partly molten rock that show slow seismic waves, while geoelectric imaging is sensitive to briny fluids that conduct electricity. Basically, it can see about double the distance of normal seismic testing as well. The seismic plume, which looks a bit like a weird sideways tornado, just shows the difference of rock and molten rock, but the geoelectric plume image shows less of a tilt and raises the possibility that the seismically imaged plume may be surrounded by a broader underground sheath of partly molten rock and liquids. So what does this say about anything? Well, not much really, unless you're a geologist. It just gives us a better look at what's really happening down there. But even if we could study it to know the exact point that it's going to erupt next, there's not really much else you can do about it. I mean, that covers the entire US in black soot that turns into concrete once it enters your mouth? I think you're gonna have some trouble getting away from that one. New subject. Recently, a small group of researchers have been looking into a small percentage of the population, which is about 1 to 3%, for whom sleep is a complete waste of time. These people are actually termed short sleepers, and are naturally night owls and early birds all at the same time. They typically go to sleep much after midnight, and then get up a few hours later, able to charge through the day without having to take naps or get strung up on caffeine. Those who do this are actually surprisingly energetic and optimistic people. The pattern of this trait sometimes starts in childhood and often runs in families, meaning that it's either genetic or some special type of lifestyle that children could be exposed to, or a combination of both. We don't know exactly how many short sleepers there are out there, but there are certainly more people who think there are short sleepers than there really are. I tend to be one of those during finals week. But really only 1 in 20 people who think they are short sleepers really are. So those of you who are watching this and think you're a short sleeper, you're really likely not. However, those of you who are, which is very unlikely, you're really hard to study because you're so hard to find. I mean, how do you get an optimistic person to think they have a sleep disorder? Because a lot of the people that came in to be in the study thought they had some sort of sleep disorder. Yet, people who are short sleepers are optimistic and outgoing, so it's kind of a weird thing to bring together. Not unlike a catch-22. Also, in case you want to teach yourself to be a short sleeper, you can try, but we really have no idea exactly what causes it. There's no surefire way to do it without driving yourself insane first. But even though we can't tell you how to be one, we can still study those who we know really are short sleepers, so we can learn more of why the human body actually needs sleep. We theorize that it's to repair bodily functional systems. But the short sleepers do exactly the same thing on a lesser amount of sleep, so there must be something else involved. But what? Also, as a side note, can you imagine how much more time you'd have if you didn't have to sleep? Or even just had to sleep half the amount of time you have to sleep now? As many people would say, more time to party! Me and my nerdy self, more time to study. Or play video games, that's always fun. No subject. On a short topic, I wanted to mention something interesting that's been observed about humpback whales. Specifically, some sort of unique compass system that they use to guide themselves through the vast oceans. Satellite tracking technology was used to follow 16 humpback whales migrating from locations off the east coast of Brazil, the Cook Islands, and New Caledonia. They found that the whales swam over 6,000 kilometers, which is about 3,700 miles, south toward Arctic waters, in a series of very, very straight lines. These lines they travel are so straight that their directions don't go off course by more than a single degree. That's hard to do even with modern tech, in a plane or a boat. Also, the sun and even the Earth's magnetic field shift more than these whales' routes, making it that much more confusing as to how they manage to go so straight. No subject. 657 new islands have apparently been discovered. However, it's not that they're new per se. It's just that they've never been documented before. Most of these islands are barrier islands, which are landforms that lie parallel to the coast, usually occurring in chain-like structures. Lagoons, estuaries, and bays often separate the islands from the mainland. A total of 2,149 barrier islands have now been identified around the world, whereas a survey a decade ago identified only 1,492. The difference is that the survey didn't incorporate satellite images, and it's not like 657 islands just went poof and appeared out of nowhere. So why is this important? It's just a new fact that you can tell your friends to make yourself look smart. So anyway, that is not all this interesting stuff I got for you, but I'm getting kind of tired of editing video. If you liked the show, hit the like button, and if you really liked the show, hit the subscribe button. Looks like I'm tickling the cat's chin, doesn't it? I can have him sit on my shoulder too. Also, let me know if you liked any of these stories in a comment or a video response or anything like that. I don't know, Facebook message, blah, 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 stuff like that. Or let me know if you've seen any interesting science stuff that you want me to share. Also, there is a bonus story that I didn't talk about today in the drop-down bar below about exploding watermelons. And it's kind of funny. So until next time, which will probably still be in Eugene, Oregon, I'm not sure. See you later, and I'm not wearing my lab coat, so I can't really go flocked, but I can try.